Hello everyone, my name is Hemu and today's we are going to discuss BPC, and in this particular BPC I am going to cover your AWS BPC and its component, AWS services inside the BPC and outside of the BPC, typical three-tier application architecture of an BPC, what is CIDR or BPC IP addressing, subnets, what is private subnet, what is public subnet. We will discuss route tables, what is public route tables, what is private route tables, right? IP addressing, what is IPv4, IPv6, private, public, and elastic IP, elastic network interface, security groups, which is a firewall over the AWS environment. We have a network access list or NACL. So these are the two components we are going to cover: internet gateway, net gateway, and net instance, egress only internet gateway. And after that we will deploy a couple of we will deploy like Linux machine, Ubuntu Linux machine, Windows server, Kali Linux, and how we will take these access and all, right? So what I will do, whatever topic I have mentioned, I will try to cover most of them, but if any of them is left, we will basically I will forward towards the next class. Okay, it's not like that. Whatever I have mentioned here, I can able to cover in one day. Okay, now let's try to understand AWS BPC. Okay, so guys, if you remember, if you will see this diagram, in this diagram I have a region which is US East 1, and this region is a North Virginia region. Okay, generally guys, we have a region. Inside this region, what we have? Inside a region we have a availability zones, right? We have a availability zone 1, availability zone 2, availability zone 3, availability zone 4, availability zone 5, and availability zone 6. So guys, in North Virginia region, we have total of 6 availability zones. Like US East 1A. US East 1A is representing the first availability zone. US East 1B is representing second availability zone, then third, then fourth, then fifth, then sixth. Okay. And guys, in couple of region, if I'll take example of Mumbai region, in Mumbai region, we just have a 3 availability zones. Okay. In Mumbai region, you will find only 3 availability zone. Now, inside these availability zone, what we used to have? We used to have a data centers. Maybe one availability zone have a one data center, or maybe two, or maybe three, right? They have a we have a data center. So what used to happen, guys, inside this particular region, what we used to create a BPC. Let's take an example. We have a, let's suppose there is a one organization called Wipro, and there is a one organization called SCL. And now this Wipro and SCL, they wants to host couple of their servers, or they wants to create an environment basically over the AWS. So what they have done, they have chosen a region which is North Virginia. And in North Virginia, what they will create a BPC called Wipro. They will create a BPC called SCL. And these are the separate BPC, means this whatever resource you will host inside this BPC. And if you will host couple of resources inside the SCL BPC, now whatever resources are as you have hosted on these BPC, they cannot able to communicate by default. Means this SCL, this Wipro has hosted whatever resources here, it is a separate network. And whatever resources we will host over the SCL, it is also a separate network. Or I can say separate data center inside the AWS. Okay. And guys, let me tell you one more thing. All these availability zones, they have a connectivity with each other, and they will communicate by using the VXLAN technology. What they will use a VXLAN technology for the communication purpose, because each availability zone is around 60 miles away, or some they are around 100-kilometer distance from each other. Okay. Now, so AWS overview. So guys, this BPC stand for Amazon virtual private cloud. Okay, it is just a virtual private cloud. I can say what VPC will provide you. VPC provide us it will give us a capability to create our data center type of environment on the cloud. Amazon VPC enables you to launch AWS resources into an virtual network that you have defined. A virtual private cloud is a virtual network dedicated to your AWS account. It is logically isolated from other virtual network account. Means, let's suppose you have a two VPC, VPC1, and we have created VPC2. Now, guys, these two VPC will denote a separate network altogether, and by default, they cannot able to communicate with each other until we allow. There is a concept of VPC peering, and that peering concept we will use to allow the communication between them. Okay, you can launch your AWS resources such as EC2 instance into your VPC. Means, now see, I'll come into this point again. Okay, you can configure your VPC. You can select its IP address range, create subnets, and configure route tables and the network gateways and the security setting. Means, inside your VPC, we are going to create the subnets. We are going to configure the route tables. We are going to configure the security groups, network ACLs. We are going to create a transit gateway, IP sectors, everything we are going to do inside your virtual private cloud only. Okay, now guys, with the help of VPC, what we can able to create a traditional on-prem type of environment. Okay, means, let's suppose in your on-prem environment you want to create a data center, right? You can able to build a similar type of data center by using the VPC. So BPC is a main component who will take care of the networking. BPC benefits of using the scalable infrastructure of AWS. It is a private address space. Okay. Now let's guys first try to understand the traditional IT network, and after that I will compare this with the BPC. So if you remember, let's take an example. Let's suppose I have a couple of servers. Okay. So these are the servers generally I'm having. Okay, let's suppose this is server 1, server 2, server 3, server 4, server 5, server 6, server 7, and server 8. Let's suppose these are the 8 servers I'm having. Okay. Now, let's suppose these initial two servers, server 1 and 2, they are the web servers. Okay. So let's suppose this server 1 and 2, they are the web server. Now we have a server 3, 4, and 5. Let's say these servers, they are the app servers. They are running some type of app related services. And after that, we have a last 3 servers. Let's say these are the database servers. Okay, now guys, generally these particular servers have a connectivity. Let's suppose this web server has a connectivity with one of the load balancer. So let's suppose in production environment, we are using here F5 load balancer. Here we have a switch. Here also, let's say we have a switch. And all these servers, they have a connectivity with these switches. And this also have a connectivity with this particular F5 load balancer. And after that, this F5 load balancer will have a connectivity with one of the firewall, right? Now guys, now this particular firewall will have a connectivity with your router. We R1 and we have R2. And these router will further have a connectivity with your internet service provider, ISP 01. And let's say we have a one more ISP which is 02. Right? So guys, these are the generally devices we will be having in your traditional environment, right? I have just designed a very small diagram, right? Not all the devices, it's just a basic diagram. So these are the devices we will be having, right? Now, see, when we have basically created this type of setup, if you want to create this type of setup, what is the first requirement? What is the very, very basic thing we need? We have to plan the IP address, right? We have to plan the IP address range, means we have to define one of the CIDR, which we will use this particular CIDR, right? Because these servers, they need a IP address by end of the day, right? Without IP, they cannot able to communicate. So we have to plan our CIDR, means IP addressing. After that, what is the second thing we have to plan? We have to plan the security. Like we have to plan how we can configure the firewall rules. We have to plan how we can basically get the internet connection. Right? May we have to think about the network address translation. What are the other things we have to basically think? We have to think about the availability and scalability. Right? These are the things which we have to consider before we will basically do any type of design here, right? These are the things we have to consider in our design. And after that only we can able to think, right? So guys, like if you want to build this type of infrastructure, what we have to do in your AWS environment, we have to also think the same thing, right? We have to think about, we will create the BPC. Now inside this BPC, we will define what is the CIDR we will use. What is the CIDR means? What is the IP range we will use here? Now, tell me one thing, guys. Behind these switches, we generally used to have a VLANs, right? And we have to basically allocate the subnets for each of these VLANs. Once we will define the CIDR, now after that we have to define the subnets. Guys, see, these particular VLANs, they will denote a subnet, right? So in AWS, we have to also define a subnet. And these subnets we have to define at the AZ level, like availability zone 1, availability zone 2, availability zone 3. They have these particular subnets. And with regards to firewall, we have to think about the security group or network ACLs. With regards to the internet connection, we have to think about the internet gateway, I gateway or the net gateway. With regards to F5, with regards to load balancing, we have to think about the AWS classic load balancers, CLV. AWS has a network load balancer, classic load balancer, then application load balancer, right? We have to think about these load balancing thing. So guys, in AWS, whatever resources you need to build, like whatever devices or whatever infrastructure you need to build your on-prem data center, in AWS, you can able to build a similar type of data center by using the BPC. With the help of BPC, we can able to build a similar type of environment. Just remember. Okay. I'll come into these diagrams again. And let me just go down a little bit. So guys, generally in traditional IT network, what we used to have a hub, routers, right? Switches, then PCs, servers, right? In AWS, what we have to, we have a BPC. Inside this BPC, we have a BPC router, and this BPC router, we can able to create these particular subnet. Inside these subnet, we used to basically deploy our servers or our machines. And now how we can able to build the setup, we are going to discuss in a while. Okay. If you will see this particular diagram, in this diagram, what I have a availability zone A, I have a availability zone B. In each availability zone, I have a three machines and the three servers which are running my web services. And I have a availability zone B where I have a three machines or three server which are running the database services, right? And guys, see this availability zone A and availability zone B is a part of one of the BPC. And if these particular machine wants to communicate over the internet, they can basically use the internet gateway for the internet connection. And if these machine wants to communicate with your on-prem data center devices, then they will use the AWS virtual private gateway, which offers the VPN connectivity or your IPsec connectivity, and they can able to communicate. Okay. Now if you will go here, let me just go on top. So guys, in BPC overview, what happens if I'll go into my AWS console, and right now I'm on North Virginia region. You can see I'm at North Virginia region. I will go into my BPC, and guys, see if you will not able to find your BPC here, you can type on search BPC. You can able to see, and you can make this particular BPC as a favorite, so you can able to see here. Okay. Now in your BPC, if I'll click on your BPC, right now I don't have any BPC, but in your case, you can able to see the default BPC. I will tell you what is the use of default BPC, but in your case, you can able to see the default BPC. Okay. Now what happens, what I will do, if I'll go and if I'll click on create my BPC. So guys, when we will create a BPC, what we have to provide a name to your BPC. Let me just put here BPC 01. Or let me just go with the like BPC Wipro. It will represent the Wipro BPC. Now, what you have to define now? You have to define a CIDR here. This is the name of your BPC. Now here you have to define the CIDR here. IPv4 CIDR. So guys, now this particular CIDR value, if you will see here, maximum CIDR subnet is select 16 or minimum is /28. These are the range of your CIDR. And I highly recommend guys, I always, most of the time I uses around /20 CIDR range. Now, how you will basically decide which CIDR you are going to use. So let's think in this way. Let's suppose Across the globe, you have around 5 data centers. You have a data center 1, or let me just write down here. Let's think about across the globe, you have around 5 data centers. You have a DC1. Let's say this data center you have in USA. You have a data center 2. Let's say this data center you have in Europe. Your data center 3. Let's say you have this data center in Sydney. Data center 4. Let's say this data center you have in Bangalore, in India. Your data center 5. These are the on-prem data centers, guys. Okay. Let's say this particular data center you have in Dubai. Now, in these particular data center, let's suppose in USA region, you are using the IP range which is 10.0.0.0/16. In Europe data center, you are using the IP range which is 10.2.0.0/16. And guys, for US region, what there are one more series will be there, which is 10.1.0.0/16, and you have reserved this particular series for the future expansion of your US data center. Okay. Now similarly here also you have reserved one more series 10.3.0.0/16. Now for Sydney you are using 10.4.0.0/16, and we have a reserve which is 10.5.0.0/16. Here we are using, let's suppose now for Bangalore we are using 10.6.0.0, and we have a reserve which is 10.7.0.0, all in /16 range. Okay. Now for Dubai you are using 10.8.0.0/16, and in reserve you are having 10.9.0.0/16. Now these are the ranges which you are having in your data centers. Now let's suppose you are also having couple of branch locations. Okay, you have couple of branch locations, and in branches you are using 192.168.0.0/16 range. Means most of the branches, they are having this particular range of IP addresses. Apart from these branches, let's suppose you have couple of HQ sites, and in HQ sites you are using a series starting from 10.10.0.0/16. Now you have couple of customers as well, right? Maybe couple of companies which is owned by you, right? And let's suppose these companies, ABC company, you have owned couple of companies, and let's say these companies is using the range which is 10.20.0.0/16, 10.30.0.0/16, and 10.40.0.0/16, right? These are the ranges used by your company. Then this is the overall picture of your infrastructure, right? Now what you have decided, now with this infrastructure, now your organization has decided and what you wanted to do, because you have a 5 data centers across the globe. You are having the 5 data centers. Okay. You have around 5 data center across the globe. Let me just go here. Let me just clear this picture. Because guys, see, when we will basically create this VPC, we have to plan this particular IP address in a perfect way. Otherwise, you will not get a chance to later update these particular ranges. You cannot able to change the things. Okay. Now what happens? Now guys, what you want? You want to use a AWS. In AWS, you have decided to you are going to use this North Virginia region. Okay. And in AWS, the another region which you want to use, let's suppose London. In AWS, let's suppose you have decided to use the Bombay region for Asia. In AWS, let's suppose you are decided to use Dubai. And in AWS, you have decided to use the in Australia also. I hope Sydney is there, but you can able to always check. Let me just see. So we have a Mumbai, we have a North Virginia, right? We have a Sydney, which is good, and we have a London as well. For Dubai related stuff, what we have in so let's suppose instead of Dubai, let me just go with what I can choose here. Couple of we are having here. So let's take an example. In Dubai, let's suppose we have decided to use this Frankfurt, okay? Because we don't have any reason in Dubai, so let's say we have decided to use the Frankfurt one, okay? Now, so guys, as you have decided to use these AWS regions, now in these AWS region, you have decided to basically use a proper BPCs, right? Let's suppose in North Virginia region, you have decided you are going to create 3 BPC or 4 BPC. BPC 01, BPC 02, BPC 03, and BPC 04. You have decided to create these 4 BPCs. In North Virginia, you have decided to you will have a 4 BPC here, 4 BPC here, 4 BPC here, and 4 BPC here. Now guys, when we will basically create these 4 BPC, and now in each BPC, what I want, in each BPC, I want 2 CIDR. I want 2 CIDR range, CIDR1 and CIDR2. This CIDR1 I will use for the current setup, and CIDR1 I will use as for a current setup, and CIDR2 I will reserve for the future expansion, right? And now each CIDR I needed around 8 subnet. And these subnets is a size of, let's suppose, /24. Or let's suppose in each CIDR I needed around not 8. Let me just go with like this. Let's say I have decided to go with each CIDR will have a 16 subnet. Here also we have a 16 subnet. And similarly, each BPC in total will have around 32 subnets, right? So guys, this is how first we have to create the overall picture. Okay, first we have to create the overall picture. These are the things which comes under the designing or the solution architect. If you are working as a solution architect or as a designer, these are the things which you have to consider. Now guys, see, Now I have the overall picture. Now I know these many BPC I needed. This is the current setup I'm having with regards to IP range, right? And now this is I needed. So what I will do now, we will basically decide what are the CIDRs, how we can basically define each and every CIDR here. So guys, just tell me one thing. If you have observed here, see, most of the time my 10 series is reserved, right? And also my 190 to 160 190 to 160 series is reserved. Now guys, if you know, we have a we have a three classes of private IPs: class A, class B, and class C. In class A, we are having 10.0.0.0/8. In class B, we have a 172.16.0.0 till 172.31.0.0/16. Then we have a 192.168.0.0/16, right? These are the three classes I'm having. And if you have observed, this class is already used. This class is already used. Now, this is the class which is left, right? And apart from that, in this particular 10 series, I do have a series which is starting from 10.41.0.0 till 10.254.255.255, right? These are the series also which is available, right? And this particular entire series is available. So guys, what we will do now, when we will design this AWS infrastructure, either we will basically choose this series, either we will choose this series. Guys, we will always avoid the overlapping. We will always avoid the overlapping. Means we will not use, let's suppose we will not use this particular 10.0.0/16 series in anywhere in your AWS infrastructure. Otherwise, we will come up with the lots of other problems, lots of connectivity related problem. Now we have to think about the netting for overlapping subnets, right? How we can make the connectivity and all, right? So guys, now if you will see, this is the entire series is free. Now what I will do, I will basically decide, I will start using this particular series. Now just tell me one thing. Is this series will fulfill my requirement or not? Tell me one thing. I need total of, I have a total of 5 regions, right? So I need around 160 subnets. What? I need total of 160 subnet. I have a 4, let me just recalculate. So 96 multiply 5, 0. I need total of 480 subnets, guys. And I hope this particular series will fulfill my requirement, right? So what I will do, I will start using this particular complete series. So this is how first we will design the solution actually. It's not like that we will blindly log into AWS and we can start creating your resources. No, we have to think about the design first. Okay, and let me see. Let me now go into this AWS North Virginia region. Let me just design the things. So I'll go here. Okay, I will go here and I will just go with my BPC01. In this BPC, what I will do, I will use the series which is 172.16.0.0/20. I'll go here. I'll create the BPC. Now my BPC is created. I can go here and I can check. When you create your BPC, you will get a one BPC ID, which is a unique one. This BPC ID is uniquely identify your BPC, just remember. And state is available, which means this BPC is available for use. And guys, you will get the DNS resolution, DNS host names. Right now it is disabled, but we can able to enable it from here. We can edit VPC settings and we can able to enable from here. Enable DNS host name. What is the use? I will tell you guys. Okay, I will tell you what is the use, but let me just enable. You will get one, when you will create your VPC, you will get one route table which is created by default for you. And if you will create multiple VPC, how you can check it is your route table? So either you can look from here. If you will click on this, you will able to get into that route table. And the best way, what we have to do, we have to basically modify. We have to go and we have to write VPC main route table. Like that, we have to rename it. When you will create your VPC, you will not get any of the subnets. Okay. Now, as you have basically seen in our design, we also wants to reserve one more CIDR, right? So what you can do, if you can go into your VPC, you go into the section and you can click on edit CIDRs. Here you can add one more CIDR, 172.16.0.0/. So in first we have used 172.16.0.0/20. If I will try to use the same one, you can see I am getting the error. What I will get the error means we cannot able to use the overlapping one. Just remember. So if I will add 192.168.0.0/16, click on save, you will get the error here as well. Okay. Let me try to add one more. Let's suppose I have decided to add 10.10.0.0/16. Here also I'm getting the error. Now, if I will use, which is 172.16.16.0/16, click on add. We are getting the error again, right? CIDR range conflict with this. Now, guys, tell me one thing. If I have a range which is 172.16.0.0/20, 172.16.0.0/20, then what is the range? How many subnets are there? What is the number here? What is the last number here? So guys, generally, if you are not good with the subnetting and all, what you will do? Always try to use the subnet calculator. Use subnet calculator. And here, let's suppose what you have decided. You have decided to check for /20, 172.16.0.0. Hit enter. So what these are the IP address belongs to this particular range, right? 172.16.0.1 till 172.16.15.255, right? Means we can next one, what we can do, we can start using this particular series after that, right? 172.16.16.0 till 172.16.31. This series, right? So if I'll go here, if I'll use this /20, you can able to see I can able to add the next CIDR here. So guys, remember, what are the points you need to remember? See, if you have a existing CIDR from 170 to 16, 0.0 from this range, then you are only allowed to use the same series CIDR here. It's not like that. With this, you are not able to use this one, or you are not able to use 192.168.1. I mean, these series is not allowed at all. Just remember, okay? So this is how we will create our first BPC. And I have modified these details here. Close. Now, as I have modified my BPC, CIDR, you can check the CIDR here. Just refresh if you will not able to see both the series here. See, both the CIDR is visible now. So I got one question, why we are not able to add the other class CIDR here. So guys, this is the limitation from the AWS. Okay, this is the limitation provided by the AWS. Okay, because they are using VXLAN in a backend for the connectivity purpose. So that is the reason they have put that restrictions. Okay, now I'll go into the subnets. I'll go here, I'll select my BPC, and I will start creating my subnet. I will create my first subnet, which is subnet 01. If you want, you can put like this. Means by looking into your subnet, you can able to see your CIDR as well. This is a 172.16.0.0/24. And as we have done the calculation, see, these are the available IP address, right? Means we can able to create here around 16 subnets. So that's why we are doing. Select your availability zone, and guys, see, now if you will check, we have a 6 availability zones. So if you will select US East 1A, then your subnet 1 will be created in this particular availability zone. And here you can define 172.16.0.0/24. Tell me guys, can I able to use here 192.168.0.0/24? No, not at all. We have to use the subnet from the CIDR range only. What we have to use the subnet from the CIDR range only, okay? /24. Add one more. This is my subnet 2, 172.16.1.0. Select the next availability zone 1V and 172.16.1.0/24. Create new one. Subnet 3, 2.0. Next availability zone 1C and 172.16. 2.0/24. So we will get around 256 IPs, not 256. I will tell you how many IP we will get. There is a trick. Okay. I will going to explain. I'm just trying to explain you here how we can create the BPC and the subnet. Then we have a 3.0. Next availability zone, which is 1D. 172.16. 3.0/24. Add a subnet here. Fifth one. 172.16. 4.0. 172.16. 4.0/24. Let me create the sixth one. Subnet 6. 172.16 5.0/24. Then I will create again the next one, 7th, here 6.0. Starting again like 1A, 172.16 6.0. And guys, I'm putting these subnets into different availability zone just for the high availability purpose, right? If one of the availability zone went down, I can still able to connect my resources using the another availability zone. Okay. Then let me create the 8th one. One 172.16 7.0/24. So guys, I'm stopping here. Let's create these 8 subnets. And now my 8 subnets is created. And you can able to see these are the subnets I'm having. Let me clear my filter. See, all these 8 subnets is created. You can able to check. And guys, when you will create a subnet, by default, there is a one network ACL is created. I will tell you what is the meaning of this one. Okay, this is the owner ID. And now if you will let me just select the first subnet, you can able to check the detail. We have a subnet ID, subnet ARN, availability zone. This is the BPC CIDR. This is the network ACL. This right now, guys, by default, all your subnet will fall under the main route table. Okay. Then this is the BPC. And guys, now here is a trick. You can see I have created this subnet with the range of 172.16.0.0/24. Now guys, from this range, how many IP addresses are there? We have a 172.16.0.0 till 172.16.255. 255 means total of 256 IP address will be there, right? But if you will see here, they are saying available IP address is 251 only. Then what will happen with these 5 IP address? So guys, just remember one thing, AWS reserve these 5 IP address. You are not allowed, see this 172.16.0.0. This is a network ID. And guys, we are not allowed to use this network ID. Then 172.16.0.255. This is a broadcast one. Broadcast IP, right? We are not allowed to use this broadcast one. And after that, we have one more IP, which is 172.16.0.1, 172.16.0.2, 172.16.0.3. So guys, now this IP address is used by the AWS router. This IP address is used by the AWS router. 172.16.0.2 is used by the AWS DNS server. And now these are the interview questions. What? These are the interview questions. If you have created a subnet of 172.16.0.0/24, how many IP address is available for use? What is the device who will use this IP 172.16.0.1? Which device will use this 0.2? So 0.2 is used by the DNS server and 0.3 they have reserved for future. I hope this thing is clear now with regards to subnet, guys. Type yes in the chat if you will understood the subnet part and how this IP reservation works. Guys, tell me one thing. Are you able to understand how we will design the IP address scheme for a BPC? How we will basically create the subnets? Okay, now. Because see, this BPC subnet route table I'm going to create every day. Okay. Every day I'm going to create these things. Okay. Now, let me just go here. Now, if I'll go here, guys, see, I will put these particular URLs. Yes, Bharat Singh 172.16.0.1 will work as a default gateway. Okay. Don't worry, I'll go through with the packet flow as well. Okay. That time you will understand. Now, if you will see, guys, if you will basically go into this particular website, let me just put this particular URL over the chat. And guys, save this information somewhere. And guys, if you want to learn anything with regards to Amazon BPC, you have this user guide. You can go into this user guide. For AWS peering, you have to go here. For traffic mirroring, you have to go here. But for this class, today's class and tomorrow class, you have to go with this user ID, this particular user guide. And here you can able to get everything. Read what is BPC, how Amazon BPC works. If you will see in this picture, we have created the BPC. Inside this BPC, we have a subnets. Now these subnets we will associate with the route tables. And after that, this route table, what we will, as we will provide a route towards the internet gateway and they can able to communicate. So guys, here you can able to get all the information. What is the IP address schemes? What is BPC CIDR? Now, if you will see generally, we will use the BPC CIDR from, we will always prefer to use the BPC CIDR from RFC 1918 range. These is the private IP address range. And these are the three ranges, and we have to take the BPC, or we have to use these three ranges when we are creating our BPC. And guys, the maximum CIDR size which we can define, which is /16, and the minimum one we have to define, which is /28. Just remember. And guys, always remember, there are a couple of AWS services who will use this particular CIDR range, 172.17.0.0/16. And so when we are designing this particular infrastructure, we will avoid using this particular series. Just remember. Okay. What are these services? Services like your AWS Cloud 9. Okay. AWS SageMaker. These are the services who are using this particular series by default. So we have to avoid using this series. Just remember. Okay. So as I have explained, we have a region. Inside region, we have a BPC, and each BPC we have a subnet. We can see in BPC, if you have observed, I have defined two CIDR, right? CIDR1, CIDR2. When we will create our your BPC first time, and that time whatever CIDR we will define, that CIDR is known as primary CIDR. Just remember. And after that, this one is a secondary CIDR. And total of 5 total CIDR we can able to define inside a BPC. Just remember. And also in a region, inside a region, we can able to create total of 5 BPC. This is the quota we are having. but that particular limit we can increase. We can have a hundreds of BPC in a region. Okay. We can basically ask AWS, they will increase that particular limit for you. But in an BPC, we just only have a 5 CIDR. One is enough. In most of the time, you are only able to see one. If there is a big environment, then two. If you have done the planning properly, then one and two only. Okay. Now, how to create this CIDR? You can read out these information. This is a very good information actually. We always avoid to use this particular series. Guys, tell me what is the reason we can avoid this series using in our CIDR range? Why we are not allowed to use this 169 to 54 series? Because it's a PIPA range, just remember. And we never use this particular series, just remember. Okay. We will not use this series as well. 10 127x.x.x. Why? Because it's a loopback IP range. Okay. So these are the basic thing we have to avoid. We have to, at least when we will design this solution properly, we will not use this particular series. Just remember. Okay. Now we have a subnet block. So as I have mentioned, like your first IP address used by the AWS BPC router, second IP address is reserved for AWS DNS, third one for the future use, right? So these are the 5 IP address which is reserved. Okay. First is network ID and last IP address is the broadcast address. Even though guys, we can also use the IPv6, but I will not discuss anything with regards to IPv6. Okay, now, so guys, why I'm providing the reference of these documents? See, cloud is a most emerging technologies. Okay, whatever I will teach you today, maybe it is not available tomorrow. So guys, always when you are doing the design, like after 6 months, after 1 year, always refer this AWS document, because here you will get the up-to-date information. Generally, Sunil, we used to avoid these range. Okay. But if you are using this particular range for creating this IPsec tunnel, which is okay, because it is, we are not going to use this IP address when we are sending the traffic towards your servers and all, right? It is just for the tunnel communication, tunnel to tunnel. Okay. It's become a point to point connection. It's not routable anywhere. Okay. Now, so guys, let me just go through with these diagrams first. So generally, what we used to do, we have a region. Inside this region, we have a availability zones, and inside these availability zones, what we use to create a BPC, and this BPC we have created for all availability zones. Okay, means BPC is a regional service which apply to all your availability zones, right? Now, what I will do, inside this particular availability zones, we will create the subnets. What we are going to create a subnet inside these particular availability zone like this. If you will see this, we have a BPC, we have a BPC CIDR. Inside this BPC CIDR, I have created these subnets. Subnet 1, 2, 3, 4, 5, 6. And now, guys, this scope of this subnet is your AZ level. Okay, this subnet has a scope till this AG level only. Whatever VMs we will deploy in your this particular availability zone US East 1A, all these particular VMs will get the IP address from this particular subnet. And guys, when we will deploy these VMs, we will deploy this VM at the availability zone level, AZ level. Okay. And now if you have seen, we have a two BPC here, BPC for Bipro and BPC for SCL, right? And we have a couple of EC2 machines or these virtual machines here. If we want to enable the communication between Bipro BPC and SCL BPC, by default, they will not communicate. But if you want to allow the communication, we have to create a BPC peering. What we can able to create a BPC peering, then only they can able to communicate privately. I'll explain, okay? And now, all these availability zones, they used to communicate with each other with the help of BXLAN, okay? And if these particular VMs wants to communicate with the internet, what we have to create a internet gateway. We have to create a internet gateway, like in your production environment. When we want to allow the communication, we have to purchase the internet connection from the ISP. Okay, so we have to create an internet gateway here. This is the overall picture. Okay, we will do these things practically as well. And as I have mentioned, see, when we have created these subnets, right? So guys, there is a one router is available, which is a AWS router. Okay. So all these particular subnets, see, I have mentioned this IP address, right? The first IP address, let's suppose from this 172.16.0.0, right? There's a one IP which is 172.16.0.1 IP address is reserved, right? It is reserved by for this router only, and this is a AWS managed router. We cannot able to do anything. We don't have a access to modify any configuration on this router. Just remember. Okay, so when these particular VMs, they will going to start communication, what they have to do, they have to send this traffic to this router. And now this router will forward this request towards the internet gateway, and internet gateway will provide the internet connection. And we have a this type of routing table. Yes, Ketan, we can able to create the same CIDR for Bipro BPC and this SCL BPC. We can able to do that. Okay. Now, in this picture, guys, if you have seen, I have this SCL BPC. So guys, we have a generally two types of subnets. We have a public subnets, means whatever VMs we will deploy in this particular public subnets, what these VMs generally have two IP address. One private IP address and one public IP address. And these VMs can able to communicate with the internet, and from internet, anyone can able to communicate with these VMs according to our configuration. We have to create a security group and all for that. Now, let's suppose these VMs is running your web services. So for web services, it's good, right? But let's suppose we have these particular VMs and they are running your database services or your application services. If they are running these web database or application services, these particular VMs we will put generally into the private subnets. And whatever VMs we will put into the private subnet, they only have a private IP address, and they are not allowed to communicate directly with the internet. Just remember, like in your, let's suppose we have a firewall, right? And inside this firewall, we have one inside network. And here we have a couple of PCs. And we have this internet service provider. Now, if these particular machines wants to communicate with the internet, what are the things we have to do with this firewall? What is the first thing we have to configure in this firewall so they can able to communicate with the internet? Network address translation. So guys, if these VMs wants to communicate with the internet, what we have to introduce the NAT gateway in your AWS. Now they will forward this request to NAT gateway, and this NAT gateway will have a elastic IP. Like in your firewall, this interface have a public IP address, right? Here also we have a elastic IP, which is a public IP. And this NAT gateway will forward traffic to internet gateway, and internet gateway will forward traffic towards the internet. And guys, if this is the case, what I will create two route tables. I will create one private route table and I will create one public route table. I'm giving these overviews only because we are going to do these particular practicals today. Okay, so don't worry. Now, so if I will give you the basics about your BPC, so what we used to have a each BPC have a subnets, and these subnets have a instance, and they have an internet gateway, right? And this internet gateway, they have a they have a route towards the internet, and they can able to communicate, right? And these are the availability zones and all. Same thing. I have just taken these particular slides from internet. So this is just an example for test environment, all right? If you want to read more about it, what you can able to find the very good example as well. If you will go into example, you can able to see this setup, read about this entire setup. What is the routing you have to configure? What is the security you have to configure, right? How you can create then with the web server and database server, right? If you will see this architecture here, what we have a web servers, and generally we put web servers into the public subnet, and we have a database servers, and database server we will always put into the private subnet. Okay. So guys, now let me just try to explain you the BPC 3-tier architecture, which is most important and everyone needs to know. So let me go here. Okay, guys, there is a one more thing I want to explain, which is a services inside your BPC and outside your BPCs. Okay. So generally what we have a region inside this region. Let's say we have a one of the BPC, right? So now let's suppose inside your BPC, we have a Amazon EC2, Amazon RDS, Amazon Redshift, Elastic Load Balancers, right? Your route tables, your transit gateway, all these are the features or the services which is offered by your BPC. Apart from like your S3, your Amazon DynamoDB, AWS Lambda, Amazon Simple Notification Service, right? Amazon Simple Queue Service, API Gateway, and all these are the services outside your BPC. So what are the services comes under inside your BPC? If you will check your console, and you can able to check all these services comes under your BPC only. Okay. Just an overview, but you will understand everything when we will discuss the things. Now, let me explain you this 3-tier architecture of an application. And after that, we will start doing the labs. Now, in this particular diagram, if you have observed, we have a project 10 BPC, which have a two availability zone, US East 1B, US East 1V. Why they have a same thing? Let me just see if I have any other diagram. I don't want to draw by myself as of now. Okay, not an issue. You can think about it like we have a one BPC, then they have a web server here in this particular subnet, and this subnet is a part of your public subnet, then we have a app servers here, then we have a database servers here. Okay. Or even though what I can do, let me just take this example. I have created one diagram just for the explanation. Let me go down. Okay, if you will see this particular diagram, guys, in this diagram, if you have observed, I have my web servers here. I have a US East 1 is subnet where I have generally my web servers. Then I have my app servers and I have my database servers. And generally these web servers I always put in my public subnet. Means anyone from internet, they can able to access these particular web servers. And now these web servers, they will communicate with your app servers. And if anything is needed, this app server will further communicate with your database servers. It's not like that if somebody wants to access something, let's say this PC wants to access something and he can able to directly query into your database. No, this will not going to happen. Always query from the internet will hit into your web servers only. This is the 3-tier architecture. Okay. Now there is a security component like network ACL and all. So this is the something which we will discuss later. Now let me go here. Just hold on for a minute. So guys, this CIDR we have already discussed, right? How we can create the CIDR, what are the consideration we have to use and all, right? All these things I have covered. This also I have told you, like generally when we are defining this BPC CIDR, we will make sure we are using this particular private classes ranges, right? Now, if you will see this particular diagram, guys, what generally we used to do, see, as I have mentioned, this my app servers and my database servers, right? We don't want the direct internet connection, like people can send the request to these peoples, right? So what we have to do, we always keep these particular devices into your private subnet. Your database servers and your app server we will put into the private subnet, and we will create our web servers into these particular public subnet. Now how we can make basically a subnet which is public, or how we can make a subnet which is private? So guys, see, we will use to create a route tables. Okay, in a route table, if we have a route towards the internet gateway, and this route table has this particular subnet, this subnet, and this subnet. These three subnet is a part of this route table who is having the default route towards the internet, which means these subnets become a public subnet. If a route table does not have a default route towards the internet, maybe it is having a default route towards the net gateway, then this particular subnets become the private subnet. Or maybe this route table will not have any type of route towards the net gateway, which means we don't want to send any type of internet connection as well. That particular these subnet we have to put inside this route table, and these subnets become the private subnets. Just remember. So BPC addressing, like understanding the CIDR, how we have to define the CIDR, right? Generally, what is CIDR? CIDR is your classless internal domain routing. The IP address for your virtual private cloud are represented using the CIDR notation. A VPC must have an associated IPv4 CIDR block, and you can optionally associate additional IPv4 CIDR blocks and one more IPv6. Means we can use IPv4 or IPv6 based CIDR ranges. Maximum slash 16, minimum slash 28 means here we will get around 16 IPs. And you guys know, out of these 16 IPs, we have a 5 IPs which is reserved. So which means if we have a slash 28 one, 5 IP is reserved, then total of 11 IP only we are getting just for the, if you want to basically use. So we generally, I have not seen people are using slash 28 one, and we have to define these IPs from this range. Guys, there is a one more tool is available, which is a paid tool, Amazon VPC IP address manager. We can use this tool like Amazon VPC IP manager. IPAM is a VPC feature that makes it easier for you to plan, track, and monitor the IP address for your AWS workloads. You can use IPAM to allocate IP address CIDRs to VPC using the specific business rules and all, right? So if you want, you can use this particular tool, but make sure this also I have basically covered, but this is a like this IPAM is a paid service. Okay, and do not use this tool because you know IP subnetting is a very easy thing, anyone can use. You can associate secondary IPv4 CIDR blocks with your VPC. When you associate a CIDR block with your VPC, a route is automatically added. And one more thing, guys, when we a routing table I have not discussed, so I will cover this part later. Now let's try to understand some detail with regards to subnet, or already I have covered this part, so not needed. Now subnet types. As I mentioned, we have a public subnet. A subnet has a direct route to an internet gateway. Resource in public subnet can access the public internet. Instance with public IP can communicate to the internet. Means if this particular subnet, if a subnet is a part of a routing table and that route table has a route default out towards the internet gateway, then that subnet become the public subnet. And the instance, whatever VMs we are having in these subnet, they can communicate with the internet directly. And what type of VMs we have to put, like NAT gateways, NAT instance, web servers, load balancer. These are the devices we generally put into your public subnet. We have private subnet. The subnet does not have a direct route to the internet gateway. Resources in a private subnet requires a NAT device to access the public internet. Instance receive private IPs, typically uses NAT for instances to have the internet access. Like your database servers and app servers, we will put in a private subnet. Apart from that, we do have a VPN only subnet. The subnet has a route to site VPN connection through a virtual private gateway. The subnet does not have a route to an internet gateway. So this is a only VPN only subnet who just have a route towards the VPN gateway. Then we have a isolated subnet as well. The subnet has no routes to destination outside its VPC. Means this particular subnet is known as an isolated subnet who is not having any type of routes to reach towards anywhere apart from the VPC. Okay. Means whatever machines we will deploy inside a isolated subnets, they can only able to communicate with each other, but they cannot able to communicate outside your VPC. Just remember. What is route tables? Route tables contains the rules or generally routes which these routes we will use for sending the traffic outside of your VPC. Means in and outside of your VPC. We have a main route table at VPC level and we cannot able to delete this main route table. Just remember, see, if I will go here, this is the main route table. Basically, when you will create your VPC, this route table is created and you are not allowed. See, if you will click on delete, see, we are not able to delete this main route table. Route tables are main route tables for VPC and cannot be deleted. Means we cannot able to delete this route table. Just remember. And guys, this Each subnet is a part of route tables. If you can able to see, these are the subnet routes. Right now, see, when we will see, these are the two CIDR we are having in your BPC, and both have the local routes. Means this particular CIDR is added as a local route, means as a local network. And whatever VMs we will put inside this BPC, they can able to communicate. Means inside this particular BPC01, whatever VMs we will install, they can able to communicate easily with each other. Just remember, because of this local route. We can also create the custom route table at the subnet level. Okay. Now guys, let me just change the things a little bit. I'll go here. I'll go here. Let me delete my BPC. So this is how we can able to delete the BPC. Type here delete. And guys, when you will delete your BPC, you can see your BPC will be deleted and your subnet will also deleted. Click on delete. You can check the details. It has deleted. We have deleted the BPC. Your subnet. Just refresh here properly. See, we have all the subnet is deleted. Route table is also deleted. So if you will delete the BPC, your subnet, your route tables, these things also got deleted automatically. Yes, Deepak, whatever VMs we will basically put in a subnet in a BPC, they can able to communicate within the BPC. Okay, by default. But you can able to restrict that communication using the network ACLs and all. It is similar like, see, generally in your local LAN infra, right? They have a proper connectivity, right, with each other. But we can able to restrict by configuring the firewall rules. So that communication is restricted. Now, let me create one BPC. BPC01 demo. I'm giving this name. I will use one CID which is 172.16.0.0/20. Created. I've created this BPC. I'll go into my route table and you can see route table is also created. I'll go here. I'll just type BPC01 demo route table. I can write here main route table. This is my main route table. Now I'll go into the subnet. Let me create here 3 subnets. On my demo BPC, I will go and I will create a subnet 01 and this is my public subnet. And I will just put this subnet in US East 1A region 172.16.1.0/24. Let me just use this particular IP range on my subnet 1. I will create one more subnet which is subnet 2, which is also public one. I will put in 1B 172.16.2.0/24. I will create one more subnet, subnet 3, which is also a public one. I will put on 1C 172.16.3.0/24. Now I will create 3 private subnet as well. I will go and I will put here subnet 01 private and I will put in US East 1A region 172.16.4.0/24, or you can go like that as well, like subnet 04 private. Go here subnet 05 private 172.16.5.0/24, and let me create one more subnet which is 6. 172.16.6.0/24. These are the three subnets I have, six subnet I have created in total. Three are the public one and three are the private one. Yes, we can able to put the like same availability zone as well for public and private subnets. Not, it's totally depends on you. This availability zone we have to just put for the high availability purpose. Because let's suppose if we will put all these subnets into US East 1A region, US East 1A only on first availability zone. Let's suppose whatever data center we are having into this availability zone, this went down. Then what will happen? Whatever resources we have hosted on this availability zone, everything is down now. Let's suppose maybe Amazon is doing some type of maintenance activity into this data center, and you have couple of VMs which are running here, right? And if this region went, this particular availability zone went down due to this maintenance, then access of these VMs is not available. So that is the reason generally what you can spread your subnets across the multiple availability zone. If one is down, then we have a second one. From there, at least we can able to access couple of other VMs, right? Now, now what I will do, I'll go here. Now let me just go and let me just create the internet gateway first. I'll go and I'll create my internet gateway. I'll give the name I gateway for BPC01, which is a demo. I'll create the internet gateway. And guys, see, when you will create this internet gateway, you have to basically attach this internet gateway with your BPC. Right now, you can see it is in detached state. So I'll go here. Let me attach it with my BPC, and I have attached it. Bharat, you are going very fast. Okay, let me first complete the things. Okay, let me just complete the things, and after that, just ask the questions. Do not ask the future questions. Okay, now see, I have created my internet gateway, and I have also attached my internet gateway with the BPC. So guys, just creating your internet gateway will not help you. We have to tell, we have to tell this internet gateway we have created for this particular BPC, BPC01 demo. Now you can go into your route table. I'll create my route table, and guys, this is the best, and this is how the things happening in the production environment. We never rely on this particular main route table. Just remember, we always create our custom route tables. I will go here and I will just put BPC01 demo public route table. I select my BPC. I have created my public route table. I'll go here and I will create my private route table. BPC01 demo, my private route table. So always just try to make a habit of creating your public and private route table. Just remember. Now, if you will go into your public route table, just select your public route table. And if you will check the route, you have a route which is 172.16.0.0/20, and this is the BPC CIDR, means whatever machines we will deploy in your local BPC on any subnet, they can able to communicate by default because we have a local route. Now I'll go into this subnet association. I'll click on edit subnet association. Now I have to allocate, I have to associate my subnets. So guys, see, if you have seen, if you go here, see, I have selected my public route table. I go into subnet association. I click on edit subnet association, and all my public subnet I will basically associate. These are the three public subnet. I will associate them with my public route table. You can check. These are the associated one. If you want to remove any subnet, you can able to remove like this. Route propagation and all we will discuss later when we will discuss the BP and another thing. See, I have created this route table, right? Now I'll go into this route because this is my public route table, which means it will have a route towards the internet gateway. So I'll go here and I'll just add one route 0.0.0/0, which is reachable via internet gateway. And I will select my internet gateway, which is this one. And this is how we have to add the route towards the internet gateway. I'll go back into my route tables. I'll go here and to my private route tables. I'll go into the subnet association and I will add my private subnet into this particular route table. Add it. And here we will not use any route as of now, because if we will add the route here also towards the internet gateway, then this become a public route table. So now I hope guys, just tell me one thing. You guys understood what is the difference between public subnet and private subnet? Just tell me. You got the idea about the public route table and the private route table? And guys, these are the things which I will do daily because I will create this infrastructure daily. And guys, remember one thing. If you will create your BPC, if you will create your subnets, if you will create your route tables, or if you will create your internet gateway, you don't need to pay anything. These are the free services. Just remember, these are the free services. Okay, just remember one thing. Now, let's discuss something more about this particular public route table. Guys, main route table I don't use. Why I am not using this route table? Because see, there's no subnet, nothing. Because see, generally I want route customization because I want my route or my traffic flow according to my according to my configuration. I want to segregate my internet traffic and my internet traffic from my like web servers, or I want to segregate my app traffic and the DB service traffic. So internet gateway is a free service, just remember, as I have mentioned. Okay, Ankit. Now, see, we can create the custom route table at the subnet level, and we have created, right? We have created a public route table and private route table. Each route table contains default immutable local route for a BPC. Means if you will check here on each route tables, it has a local route, right? You can check private. It has this local route, and see, you are not able to delete this route. See, you are not allowed to do anything. We cannot able to delete this route. If I'll go on my public one, let me just go into this public route table, route, edit route. See, this route I can able to remove, but this is no, I am not able to remove because it's a local route for my subnet, for my BPC CIDR. Okay. If no custom route table is defined, then new subnets are associated with the main route table. So guys, if we will not create any of the custom route tables, all your subnet will fall under this main route table, which by default created when you will create your BPC, which means this route table. Let me create one more subnet here. Let me just create one more subnet just for a demo purpose. Let me just use this subnet for jump box. I will put on 1F 172.16.0.0/24. Create subnet. Go to into route table. Go into this main route table. Subnet association. You can basically associate this subnet with your main route table here. If you are not, you don't want to put into the custom one, then just put here into the main route table, just remember. And if you will go into the subnet, you can expand it, jump box, you can able to see the details. This is the route table, and here you can able to see this is the main, this subnet is a part of main route table. And guys, always remember, see, in production environment, here you will get lots of subnets, right? And if you want to see a subnet with regards to a BPC, what are the subnet belongs to which BPC, you can copy this BPC ID, go here, and you can just put this BPC ID here and filter. You can only able to see all the subnet related to this particular BPC. If you want to see the route table belongs to this BPC, put here, you can only able to see the route table with regards to this BPC, because in production environment you have around 10 BPCs, you have around 100 plus subnets, right? So this is how we have to filter it out. Okay, just remember, we can able to modify the main route table according to our requirement if we want. Now guys, everyone know route priority. Guys, how your router going to make a routing decision? Let's suppose I have a route 10.0.0.0 and it is reachable via next hop, which is 10.10.1.1/8, 10.0.0.0/16, which is reachable via next hop, 10.20.1.1, and I have one more 10.0.0.0/24, and this route is reachable via next hop, which is 10.30.1.1.1. Now, which and these are the routes I'm having on my route table. And let's suppose there is a one PC who has sent a TCP request on port 22 towards 10.0.0.10. This is the IP address where he is sending this request. Now, which route it will prefer, guys? Which route it will prefer? Write on the chat. So let me tell you guys, I see around 40% people has given the correct answer, but remaining has put the wrong answers. Let me tell you, route preference happens on the basis of longest prefix match. This is the first thing. Means if, see, this particular subnet is a /8, right? This is a /16, this is /24. Means longest prefix match, which is this. These three bits are fixed, right? For this particular destination. So what it will choose the third route, because this is the longest prefix match first. Means it will send this request to us 10.30.1.1. Longest prefix match, route priority and propagated route, and after that it will basically check for the route priority or the propagated routes, and after that route priority and prefix list. So this is the order it is going to follow. And when this order will help you, it will help you when you will configure the IPsec VPN with the help of BGP, because that time you will get couple of propagated routes as well. So this route priority will help you. Longest prefix match, then route priority and propagated routes, and the route priority and prefix list. Just remember. The route table, guys, there is a quota. You cannot able to create n number routes. Okay. Oscar propagated routes generally you will receive when you will configure the IPsec tunnels using BGP. Okay, I will explain you these things when we will discuss this IPsec tunnel. I will configure the BGP. Okay, that time route. So guys, there is a quota on the number of route tables that you can create per BPC. There is also a quota on the number of routes that you can add per route table. So guys, there is a quota, right? And if you want to check, this detail like BPC per region, you can able to create 5. BP subnet per BPC, you can create 200. IPv4 CIDR, you can create 5. IPv6 CIDR, which is 5. DNS, you can send 1024 packets per second for a DNS. Elastic IP address, you can reserve around 5. Elastic IP per public net gateway, which is 2. And you can always check this quota. So I have put this particular link, and always check out this particular link on the go here, and you can check out, you will able to get the quota details, BPC and subnets, right? And these quota will help you in the exam perspective. Okay, so go through with that. Like gateways, you can able to create around 5 gateway per internet per region, right? Net gateway per availability zone, which is 5. Private IP address quota per net, which is 8, right? And you can increase, like you can able to increase this egress only internet gateway per region by requesting with the AWS. So you can able to check out all these details. It's very hard to remember all these things. Okay, so always refer this link for the same thing. Now go back. So I'll go here. So guys, with regards to route table, because see, if this machine wants to communicate with this machine, we need a route, right? Without routing, they cannot able to communicate. Just remember, right? So generally, as I have mentioned, inside a BPC, they have one local route for 10.10.0.0/16, right? And both machines, they can able to communicate easily because we have this particular local route in our routing table. So same thing here as well. You can check it out. They are saying, can these machines able to communicate with the internet? These machines can only able to connect with the internet if you have an internet gateway, and that internet gateway you have attached with your BPC, and after that you have one default route towards your internet gateway in the route table, and then that route table has associated with subnet A and subnet B, then only both machines can able to access the internet. If let's suppose only subnet A we have associated with this route table, then subnet A machine can able to communicate with the internet. Just remember. Like in this diagram. In this diagram, you have seen, we have a subnet A, we have a subnet B. Now, this subnet A have this particular EC2 machine, and subnet B have this EC2 machine. If this subnet A this EC2 machine wants to communicate with this EC2 machine, they can able to communicate. But let's suppose we have a dedicated route table for subnet A, and we have a dedicated route table for subnet B. These are the custom route table which we have created. Let's think about, this is my public route table and this is my private route table. So because my public route table have a route towards the internet, so this machine can able to communicate with the internet, but this machine cannot able to communicate with the internet because we are not having any route on my private route table towards the internet. Just remember. So how your machines is going to communicate, it totally depends on the route tables which we are having. Read about this route table concepts, guys, on the same place on this user guide. Okay, there is a route table concepts, subnet related concept, route table related concept. Just read through this particular thing. What are the meaning of all these things? It is just like we have to define the target, the next stop, that's it. Okay, so these are things, just go through with that. It will really help you. And you can also able to understand, like we can create a custom route table like that, right? We can create one route table for this subnet so it can able to reach till the internet. For this subnet we can create a route table if we want to allow the communication till your corporate data center via VPN gateway, right? We have to add the route towards this VPN gateway, then only it will work, right? So read through these documents, they will really help you a lot. These are the examples. Go through with these examples as well. How you can work with the route tables. These are the some document which will really helps you. Yes, Oscar, we can have a two internet gateways. We can have a two net gateways as well. Don't worry. Okay. Now, quota we have seen. Let's go down. Internet gateway, I have already explained, right? This is the device which we need to create, or this is the BPC component which we need to create. We want to allow the communication for our VMs with the internet. Okay, without internet gateway, our VMs cannot able to communicate. Now we do have a one more internet gateway, which is a egress only internet gateway. And guys, see, this egress only internet gateway we will use for the IPv6. Because in IPv6 there is no public or private. Everything is private. Everything is public. So for this type of devices, we needed a egress only internet gateway. Okay. So if you are using IPv6, then use the egress only internet gateway. Now guys, what I can do, let me just explain you some IP address related things in your BPC. Or what I can do, let me just do the practicals. Before going into the practical, just wanted to explain one more thing. See, in your AWS, we have a three type of IP address. We have a private IP, public IP, and elastic IP. So guys, your public IP and elastic IP are same. What is the main difference between public IP? See, let's suppose your machine. We have launched one VM. This is VM1, and it has get the public IP address, which is 151.7.100. If we will restart this particular machine, or if we will reboot this machine, next time maybe we will get some different IP address, maybe 7.200 or maybe 161.7.70. Means the IP address is not fixed. It is getting the public IP address, but it is not fixed. If we will use the elastic IP, which means let's suppose elastic IP is IP address which we will allocate from the AWS public IP range. Okay. And when we will associate this particular elastic IP with any of this virtual machine, which means now that machine will get the fixed IP address. Remember one thing, guys. See, if you will basically allocate the elastic IP from AWS, it's free. But it is only free if you have allocated, if you associated this IP with one of the VM. If you have not associated this IP with the VM and you have just booked that IP address, but you are not using it. If you are not using it, then you have to pay for this IP address. Just remember, you have to pay for this IP address. Now, private IP address communication has within the VPC. Public IP address, we can communicate over the internet. Elastic IP also we can able to communicate over the internet. Address range, get the IP address from the subnet, get the IP address in case of public from the Amazon pool within the region, and Elastic also get the IP address from the Amazon pool within the region. When your instance is restarted, your private IP address once assigned cannot be changed. Change over instance restart means if your machine will restart, this public IP will change, but elastic IP will not change. Okay. Releasing the IP address, release when instance is terminated. In case of private, released to the pool when instance is stopped or terminated. Not released remains in your account. And if it is remains in your account, then you have to pay. It is chargeable that time. Automatic assignment means this private IP address, it is automatically assigned from your subnet. And this IP address is also automatically assigned from the public IP pool of AWS within that region. But that particular option you have to choose. You have to define you want this public IP in your machine or not. Just remember. This also you have to basically define you want to allocate the elastic IP address to your machine or not. Or we can also later on also we can attach this particular static IP into your machine. Example, generally your application servers and database servers, they have a private IP. Generally web servers, load balancer or website have a public IP, and your web servers, load balancer and website, they have a elastic IP as well. Okay. So these are the things, and you have to remember this particular table.